So here is an example of one of the extension challenges, getting two lights to blink instead of one light blinking at the same time. In this case, I put on the prototyping board two different solutions to that. I've seen one solution already from one of the students, and so I wanted to show that there are actually multiple solutions, multiple right answers, and that's actually, I encourage you to play with things like that. Again, in the spirit of making, is really to try and understand the world you're playing in and developing in, is to see what are all the possibilities that are there, and what can you understand about them. So you'll notice in the first one, the circuit, this is the first one right here, we've got these two lights that are blinking at the same rate at the same time. And here is our pin that's going into pin 13 over on the Arduino board. Goes into a resistor to the ground and out. And you'll notice that if you look close, you can see that the LEDs are staggered. So the first LED is on the same, has one input. The anode is on the same row as that green wire coming from pin 13. That bridges over to the next row, where then, so the cathode is now in line with the anode of the next LED, and then its cathode is in line with the resistor. Now the interesting thing about this one is that if I take out this second light, the second LED, you notice that it actually stops the first one. That's important to understand because that's actually getting at the difference between a serial and a parallel circuit. And that's something that you may want to play with or look up if you're not familiar with that terminology. You will be working in both parallel and series circuits, and so there's one that's actually a series circuit. And think of it as the old Christmas light string, where one bulb is burnt out, the entire string does not work. So, but you'll notice that when I pulled that out, the second light that was here kept blinking. So clearly it's on a separate circuit. So what you actually see on the board is a series circuit and a parallel circuit. So here's a series. So when I pulled one out, you notice that the other one went out, so that's your series circuit. And over here's our parallel circuit. When I pulled the one out on this first circuit, the second light continued to go. Now in this case, what I did is I went over and I actually ran another pin, in this case off of pin 11, a wire coming over to an LED. Same thing, set it up to, the anode is on the same row as the yellow wire there, and then the cathode is in line with the resistor back to ground. Now in order to do that, I had to make some changes to the code. So you'll notice here, started off, I actually called it now LED 1 as off pin 13. That's what you're used to seeing already, and in this case I just put the the series circuit there, so that's how that works. But I defined LED 2 as a separate circuit, and it's coming off of pin 11. Once I did that, I had to set the pin modes for both of these to output so that it knew that it was going to be sending a signal out to those rather than waiting for a signal to come in. And then in the loop section, this just runs over and over and over until until you stop the program. I have a digital write to both LED 1 and LED 2 as high. My delay is still 1,000, and then I do the LED 1 and LED 2 low, and the delay is 1,000. So now all of these are running at the same rate. There's my delay of 1,000, and they all run at the same rate, and it actually has two different circuits, two different pins controlling the circuits on the board. So that is just a solution, and actually it's two solutions to the same problem.